Okay, sets, day 1. First, we need to review what we learned in the beginning of the year. A set is a collection of numbers or objects. So maybe we'd have subset A with the numbers 1, 2, and 3. And subset B, the numbers 2, 4, and 5. An element is a number or object in that set, so 5 is an element of B. We might write that as 5 is an element of B. Union means or. We use the little U symbol. So in this case, A union B would be the numbers that are in A or B, so that'd be all of them, 1, 2, 3, 4, and 5. And intersection means and we use this little upside down U. And the only one that's in A and B would be 2. Okay, we've also talked about, or the new stuff is disjoint or mutually exclusive. That means there's nothing in common. So in this case, A and B are not disjoint or mutually exclusive. Instead, that would be no common elements. So they don't have anything in common. A subset means one set fits inside of the other. So maybe we have some set C that just has a 3 in it. We also have a set D that just has a 4 in it. Set C and D are mutually exclusive because they have no elements in common. And set C is a subset of set A. Because the number 3 fits all the way inside set A. And then empty set would be just a set with nothing in it. And we list it like this or like this. And we talked about all of this in the beginning of the year. What we're going to add now is counting sets. And you count a set by saying the number in that set. So for example, the number in set A. And in this example, the number in this set A is 1, 2, 3, 4, 5, 6, 7, duh. So end of A is 7. The number in this example we're counting by 2, 2, 4, 6, 8, all the way up to 100, so it should be 50. So the actual definition for n of A then is it represents the number of elements in set A. So we're counting them up. We have finite sets and infinite sets. The previous two are finite because there was a fixed or final number of numbers. Finite number of elements. And then there are also infinite sets, which means they have an infinite number of elements. You may have to pause to write this down. For example, Z, which is the integers, positive and negative integers. That goes on forever. So at the number of elements in Z is infinite. Okay, for R, the number of elements in set R is also infinite. It's every single number out there that you could possibly write, on a number line. And then this last one, it says all real numbers between 2 and 3, that's set K. Well, that's also infinite. Because between 2 and 3, we have 2.1, 2.2, 2.3, 2.33. We have a zillion, or as a matter of fact, an infinite numbers between 2 and 3. And what's interesting is that notice all real numbers is infinite, and just the numbers between 2 and 3 are infinite. So we have two infinities of different size. Because all real numbers, that's every number from negative infinity through 0, between negative infinity to infinity. That's infinite. But then we also have this little subset here. This is 1, 2, and 3. This is also infinite. So we have an infinity inside infinity, which is kind of crazy, different sizes of infinity. So again, n of z then was infinite. N of the empty set is 0 because there's nothing in there. All right, we're going to skip this problem until the end and start on the next section. So the goal for the next section, is section 3C, is to know Vine notation and complements and to understand and use set notation. So first off, we have this, some set A, and it's the way you read it is that the set of all x, this means the set of all, this means such that the set of all x, that's what this part means, the set of all x such that x is an integer between -2 and 4. So x is an integer, and I should erase the screen. Where x is an integer, that's that part, x is an element of z, and it's between -4 and 4, including -2 and 4, including -2 and 4. So you actually need to memorize this. The purple part is the set of all x, the yellow is such that, the green is that x is an integer, or x is an element of whatever set, and it's between -2 and 4, and it's including -2 and 4 because of the little equal sign right here. Okay, we could also write this set like this. Okay, the integers between -2 and 4 are these. And then if I asked you how many numbers were in that set, well, that's 1, 2, 3, 4, 5, 6, 7. So we have 7. N of A of set A is 7. Here's another example. Okay, and I'm going to let you write the meaning of that set builder notation. You will do this before class. Okay, and it says list the elements of set A. Well, I can't because A is irrational numbers, so it's going to be 20 to 22, all the numbers in between it plus all the fractions. So I really can't answer that question. And then find the number in A. Well, Q is rational, so there are an infinite number, and I'll let you look up what rational means if you need to. All right, the next part is D, complements of set. And we need to talk about, we're doing this one with an example, this U. The universal set is all the numbers we're talking about. So in this case, we're going to say, I'm going to match the colors from above. We have the set of all x such that x is an element of the natural numbers. So no fractions in there, no negative or positive, no negatives. Okay. And the numbers are between 1 and 8, including 1 and 8. So I could rewrite that as the numbers 1, 2, 3, 4, 5, 6, 7, and 8. My brackets are always kind of weird looking. So there are different ways to write it. And you can see that if it's a finite numbers, maybe the natural numbers or z, you can just list them out, and that's almost easier than using this notation. But for up here, I really can't just list the elements. So I actually have to use the fancy notation. And then we have some subset A with just the numbers 1, 3, 5, 7, and 8. So A has the numbers 1, 3, 5, 7, and 8. So it is a subset of U. We could write that down. A is a subset of U, and it should be because the universe contains all the other sets we're going to talk about. And what we want to look for is the complement of A. And the definition of that is the set of all elements not in set A. So the complement would be 2, 4, and 6. So A complement, it's either given by this little tick mark, or you might see it like this, A complement. And that is going to be the numbers 2, 4, and 6. Okay. And then we have some relationships. Remember, intersection means and. Are there any numbers in set A and set B, any of the same numbers? And the answer is no. So that will always be the empty set. There's nothing in there. A union B, or sorry, excuse me, A union A intersect. So I lied. A union A complement. Let me say that again. A union A complement. That would be putting them all together. So we'd put all of these numbers together with all of these numbers, and we'd be back to the universe. We'd have everything in the set. And then it wants you to know that the number in the complement, which was in this case 1, 2, 3, would be the same thing as the number in the universe, 1, 2, 3, 4, 5, 6, 7, 8, minus the number in set A, 1, 2, 3, 4, 5, which makes sense because they're just pieces of the whole. All right, now we have some Venn diagrams, and I'm actually going to put this part on a separate video. Please turn to part 2.